All right. Good evening. Good evening, folks. And skål. Cheers. I think we already had this one on stream, but it's Jungle Joy, also by Brussels Beer Project. It's a passion and mango ale. Very fruity, as you might think or might have guessed. Right. Last night we managed to solve day 6 completely on my own, I have to add. No one actually helped me. No, just kidding, of course. Amar was a great help there. Today he would be playing Dungeon World or something or the other. So we are on our own in trying to implement day... What's it today? I don't know. Day 7. Man, blanking out on the days. So I have this issue again where IntelliJ is showing the prompt on my other screen over there. And I found the trick to fix it. When you exit full screen and you re-enter, then it should be... Oh, godverdomme. I was gonna say it should be fixed. Maybe it only works if you're in presentation mode already or something. Let's try that again. Okay, that sucks. Then I don't know what to do. Maybe if I do it like that. Now we've reset it. Yeah, okay, great. Otherwise I would always have to restart IntelliJ for such a silly reason. Let's just run the tests already, but we get that slow startup out of the way already. And my plan my plan now is to first figure out how this works. So if we just try to find the most optimal horizontal position between these two, and then we just add another one and then add another one and then see if we can come up with an algorithm for that. So we can already add some tests, I think. I'll go baby steps. I don't know how to give that thing a good name. So let's first create a list of integers. What was it, 16 and 1, I believe. So it's like the initial input. Let's call it input. And then we want to get the, what was it, find most optimal position between, for this thing, and call that thing actual. We'll say that it's an integer, but really it's a position. Now I wonder if I want to type it properly this time, because both fuel and positions are gonna be integers. And it might get confusing, or it might not. We don't really know yet. So I was thinking maybe if I make it explicit now, then we'll have a good idea or something, but I don't know. Is equal to, and maybe we can just inline it, because it will always look the same. And I don't know what it should be, in fact. Input or positions, let's call these. A list of integers, and it should output some position, something like that. what is the most optimal position between these two? So if I have to move a crab from 16 to the middle, so how does that work? So just take 16. If I just deduce 8 from that, I will get 8. And that means a 1 plus 7, that's also at 8. In that case, or at least that's how I think it should work, right? So then the total fuel amount would be 15. And if let's say if I don't go to 8 but I go to 9 or something, isn't it always going to be 15, I guess, which would be 16 minus 1? Let's see if that's indeed the case, huh? So I would go from 16 to 1. That would mean minus 15, then we are at 1. Yeah, and then 1 should remain. So plus 0, I guess. And then that would be still at 1. In that case, it's still 15 plus 0. So maybe we're onto something already. Oh, wouldn't that be a first? So I guess the first part we could implement as position first. These would be positions minus positions last or something. I guess that only makes sense if we want the highest number of these two, I guess. Is there a thing for that? I think we tried to write that last time as well. If we do an int range, start and end, I'm not sure if we do that, if it automatically does start at the at the first. And progression. I think the direction it's going in is dependent on well, let's see. Oh, it doesn't really say. Let's do a bit of a Kotlin sketch file. And then we can say from 8 to 1. What does that look like? Jong toch. For each. We'll do println it with a new line. Jesus, I really wonder why there it says down 2. That's why it's not printing anything. Okay. So if you do 1, 2, 8, voila, then it is giving us some output. So we still would need to figure out which one of these two is the larger number. But then why would you put it in a range? Let's assign these positions. And then we want the minimum of the either one, so pulse 1. So what I expect then is this is min, this is max. I don't know how to properly call that. Let's just say we've got a minimum with another integer, and it should return a pair of two integers. And then we'll just compare if this is strictly, or maybe if other is strictly larger than this, then return this to other, and I guess else it will be other to this. Something like that. Okie dokie. And then we would just do Ise max minus min. What's up, Topher? Are you my backup tonight? Since Amarth isn't here today. That bastard. Yeah, so the optimal position here would be max minus min. Or it doesn't really matter, in fact. It will always be 15. Just the distance between those two. This should work. Oh yeah, we need to make sure that it is 15, of course, huh? Then it will work. Then let's increase the amount. So then we add 2 in the mix. So now there's a 2. Can we then say right now what we have is if we check the distance of 15 between these two, what if we do the 15 towards the 2, what would it then be? How so is most optimal plus 15 when you have 2 crabs, but it's 1 crab at position 16 and 1 crab at position 1. I don't know what the optimal position would be. You have to move them anyway. Either you move 1 to 16, then he's spending 15 fuel, or you're moving 16 to 1, you're still spending 15 fuel. If you move 16 to, I don't know, 8 or something, then from 1 to 8 would be 7, and 7 plus 8 is still 15. Oh yeah, yeah, it's the, yeah, based on cost, I would say. What is, but wait, maybe I need to read the thing again. Determine the horizontal position that the crabs can align to using the least fuel possible. How much fuel must they spend to align to that position? Yeah, it's indeed find most optimal costs. It's not the position. Fucking hell. At the beginning of the stream, I said, let's make types for these things so that we don't get confused. Here we are getting confused. So let's make a type fuel. These are positions. And then we'll just make two aliases. Type alias. Then at least we'll make things a little bit more concrete without having to do or to work ourselves into annoying positions, let's say. Thank you for that suggestion. That was really useful. But then what? So if we add a 2, then it no longer can be 15. But I don't really know what it should be then. So if it is, we can do the same thing with 16 to 1. If we just compare this one to the 16, we would end up with the same thing. It would be 16 minus 2, so that would be at 14. So let's say that we come up with 14, so at position 14. We've determined as the ideal position. Wait, maybe let's try 15 first, because that's the initial thing here. If it's at 15, then we need to spend 15 minus 2, which is 13. We need to spend an extra 13 fuel. So that would mean 13 plus 15 is 28 fuel spent. Now what if we take something more in between? Wait, is that correct? So that's the case when we're going towards 15. What if we then put our position at I don't know, 2? In that case it would be 14 fuel spent plus 1 fuel spent plus 0 fuel spent. So here it's 15, right? Why would it be plus 1? Why is it plus 1 though? Yeah, here it's not logical anymore, I think. Yeah. So if it's 15, then that means to go from 16. So here it's initially 1 to go from 16 to 15. So it's 29 indeed. But here it would be 15 fuel spent. Even 14. It's 14 and then 13. Yeah. I don't know how I got to that weird conclusion. It's maybe because I'm super bad at math. But then at position 2, I think this is a very low number. Maybe it's a good idea to optimize for no fuel being spent. Or basically check out which numbers are lying very close to each other. Luckily this exercise is not math heavy at all. Yeah, neither was the last one. Yeah. These are the ones where I'm usually learning the most, but then not really learning anything at all. At least the beer is good. And I've got no real approach here to determine the most optimal fuel spent other than just trying out stuff, you know? So let's say, just for shits and giggles, we put ourselves at 3. Then that would mean we can spend less fuel here, spend more fuel there, spend more fuel here. So then we already end up spending 16 fuel. Now, just for shits and giggles as well, if we do 4, it's 2. Here it's 3. Here it's 2. So it's still 16. So does it stay at 16? Or what if we go to 1? If we go to 1, it's 15 here, 0 here, and then 1 here, which leads to 16. This is a bit weird, I guess, because I would have expected this to also be a good idea, like here. It's already closer. If you move the position to the left, all crabs to the left of that position will be 1 cheaper, and all crabs to the right of position will be 1 more expensive. So if we sort them and we find the middle index, so to speak, then that would be the most ideal position to go to. Because in the case for 16, 1, 2, that would turn into 1, 2, 16, then 2 is the best position to go to. But what about positions that are not in the list though? Or do you just have to generate? Yeah, so if you take the minimum of this list and the maximum of that list, and then you just generate a sequence of numbers, which are the positions, and then you just take the middle one, then that would be the most ideal position. What do we have here? So here it would be 37, huh? So let's just verify. Yeah, I guess I could write it. Fuck, no longer correct. Fuck me. That's funny though. Oh, why is it? Yeah, of course not, because then no, it's important that it's only the positions of the crabs, because they are the ones moving. Otherwise, the rule doesn't add up anymore. And that, wait, huh? Yeah, and basically, the moment you found the position, it's just calculating how much fuel was spent towards that position. And then we good. Oh yeah, that was like a very important tip to get. Ten crabs at position 1 and 1 at position 10. It is clear it should be 1. Yeah. Yeah, the middle is 5, yeah. Yeah, that's a fair point. Yeah. Okay, let's try that. So here, instead of doing 1 and 2, we need to find the minimum. Sort, I guess. Sorted, take first. Let's do that once. Ah, here's a. And then this would be max or null. What happened to max? Oh, Michelle says hi. Say hi to Michelle. Say hi back. Holy shit, it's been a long time. Deprecated. Show me why. Use max or null. Oh yeah, it already had the question mark, so they wanted to make it consistent because everything everything that is returning a optional should be returning or should be mentioned or called or null. All right, so we've got 1 and 2. Then we've got the minimum or the maximum, and now we want to find wait. Yeah, because iterators can be empty. Maya, for our case, we know that it won't be, of course. I already lost track of our thought, because now we want to find a position in the middle between these two. I already forgot why I just no, that's not what I wanted to do. In fact, I'm such a dumbass. What I want to do is just sort them first and then get the crab at the middle position. So crab at middle. Grab in the middle. This should return a position, and this should be yeah, I hope I can just do this because divided by 2, or if I use this, then it will turn into an integer and then it's fine. And I think this will round up, I believe. I don't remember. I can't really see that. We will round down. Thank you. So then when we have the crab in the middle, that's the position that I want to move. So this is the most optimal position. And now the only thing I need to do is calculate. So for every positions, I sort of want to loop. And I guess what I want to do is fold to start with 0. And then I want an accumulator and a current position or something. And I want to check is there a way to do minus in a safe way? Just, or the difference. diff between current and grab in the middle. So let's write that. Fun int. Maybe let's put it on position. Other position. Why not reduce? Yeah. What is reduce? What's the difference again? Then you don't have to start with anything. Yeah, it's the same, huh? But I guess a little bit more expressive. Wait, why not? How is it? How will it not work? We're always using cur anyway. Yeah, okay. You don't have an accumulator. That's the problem, I guess. With the reduce, you take the immediate or the first thing in here. Okay. So I want the diff. I want accumulator to be added with this part. And that we're going to write right now. And I don't really have a good way of doing that. So maybe let's do this minimum with other. And then we'll assign that to min and max. And then we'll just say return max minus min. And then we always have a positive number. And this should return an amount of fuel. So, voila. Yeah, and then we just return that. So let's see if this is still 15. Tjoe, dat is toch tasty hoor. So what did we discover again for 2? It should be also 15, I believe. Absolute with a minus b would also work in Kotlin because ints are signed anyway. Okay, wacht hè. So that's math.apps, I think. But if it's a minus... yeah. That only works because we don't have negative numbers, right? Otherwise you might increase the negative number. Yeah, indeed. Yeah, I guess this is a little bit safer. Is it? No, not really. This is the same issue. You just add, or if it's minus minus, it will add it, I think. But yeah, that might be better. Huh? Is it identical? Then let's write it like that. We want this minus other. Then we don't need this stuff. And we can convert it. What's your problem? Oh, okay, there's a Kotlin function for that. Okay, I didn't know that either. Zo, mooi. Let's put this stuff on one line. And then I feel like we can try this. So instead of doing solve one, maybe what we can do is call this thing input or something. Or we move the function to the production code. Let's do that. We had fuel here. That's funny. So solve 1 would be a return find most optimal cost for input. Voilà ça. Yeah, and then we just run this. It should be good. It's not good. It's not compiling, in fact. We rerun because we didn't first compile it. Sad. Yes, great. Then we can just run this. And it should return this number. Let's try that as answer. Yeah, I have to say, Topher, that's a dead giveaway, the finding the middle. That's very cool. But now what? We've got some new input. Here it's this part maybe. Well, let's first read it. These crabs, they don't seem interested in your proposed solution. Perhaps you misunderstand crab engineering. As it turns out, crab submarine engines don't burn fuel at a constant rate. No. Instead, each change of one step in horizontal position costs 1 more unit of fuel than the last. The first step costs 1, the second step costs 2, the third step costs 3, and so on. As each crab moves, moving further away becomes more expensive. This changes the best horizontal position to align them all on. In the example above, this becomes 5. Matter of fact. This costs a total of 168 fuel. Determine the horizontal position that the crabs can align to using the least fuel possible so they can make an escape route. And it's again the question on how much fuel. Yeah, so solve 2 would be test input at least 168, and then we can go here, say solve 2, and now it's find most optimal cost with exponential fuel consumption. What a long name, yeah. How do you call it? So from 16 to 5, it would be 66. Why would it be? Yeah, okay. They realized that it was 5 already, but which one is close? Alright, here they're spending 3 fuel. It's to the power of 2, I think, then? No. Is it... how do you call that? With the exclamation point? Factorial. Or something. 1 plus 2 plus 3 is 6. Yeah. Oh, oi, oi. Sending me Wikipedia articles. Oh my god. Why heck? Moonshine theory? Is that what I think it is? Nope, it's definitely not what I think it is. Ah yeah, it's those triangular numbers. That's fun. Oh my god. I don't know any of this. So now you've shared this article with me, and I understand that it's a series of natural numbers. The nth partial sum of the series is a triangular number. Wacht, hè? So I guess if I then... It would be the same, I believe. Yeah, can't do that. I was gonna say if I first map them all... Wow, that's gonna take too long. Oh, okay. Ah, that's the formula. Okay. It's n plus 1 divided by 2. Ah, yeah. I don't know if you call it exponential fuel consumption. Maybe I should just call it 2. Hier ze. Maybe the answer is 0. You never know, huh? Nee, I guess we can't really do the same idea there, like taking the middle, because those crabs, it no longer means the same if you take the middle, or does it? You know, we can just try it out. Yeah, middle no longer work. Ah, yeah, of course not. I mean, I wrote a test saying it won't work. Jesus Christ. Let's do the one for 2 and then see how that would work. I guess maybe now I can write it in this class first. A linst. Jesus fucking Christ. Yeah. I don't think I can solve it mathematically then. Maybe if I first try to do that already. Seems like that's important. Yeah, it's just like yesterday I was thinking, oh, maybe we can do it with dynamic programming or something, but then still that's gonna take me so far off. Moving further becomes more expensive. DP can hurt you from behind. Oh my god. That's very funny. Yeah, so I'm just thinking if I implement this kind of stuff, or if I'm able to calculate this even, what will it be worth? Is it going to bring me to a solution or not? I guess I will always need it, because if I keep the positions, or if I calculate this position, I will always need to calculate that thing. Holy she snacks. Software crafting Lyon. What's up, lads? Bonsoir. Bonsoir à tous. Comment ça va? Now I feel like I have to talk in French. C'est fini là-bas ou quoi? Ah, cheers. Thanks for the raid. Maybe you guys can help me out with the solving part 2 of Advent of Code. Yes, I figured. My beer is empty. Fetch me a new one. I was drinking this one. It's called Jungle Joy. It's you might know this because they have the same brewery or bottler, I guess, in Paris or something. I don't really know. Mathieu B. Good evening. Yeah, we solved the first one. Maybe I can go over that solution. With a lot of help from Topher in chat, we came to this conclusion. If you just take the middle and then we just calculate how much fuel every crab needs to spend to get to the middle, then we find the optimal fuel, or like the fuel cost. But for the second part, we're a little bit screwed because instead of going from one position to the other, instead where we thought, it's just going to cost one fuel, it actually costs much more. And maybe I can start writing this kind of function first. So if I want to move, maybe let's go to the test again and then write something like calculate fuel spent between two positions. This should return an amount of fuel. So don't worry, both position and fuel are integers. At least if I import the correct one. Yeah. And this we can discover if we again find the diff between these two, false 2. That's gonna return us, I think it might say that it's returning fuel, but that's incorrect. It's really positions now. Steps or something. And then to find fuel expenditure, it would be for steps. This should return fuel. This is an int. Then we can say, what was the thing again? It's steps plus 1 divided by 2 or something. And then that times steps or something like that. Yeah. So we just return fuel expenditure for steps, and then that should be the outcome. So if I then try that, so if we say assert that calculate fuel spent on my IntelliJ, it's right underneath you. Oh, voilà. If we do from position 1 to 5, it should be 10 is equal to 10. Let's do some other examples. 7 to 5, it would be 3. And then 14 to 5, it would be 45. This would be fuel expenditure, I guess, between two positions. Was it the DDD? Did you guys discuss the DDD group or something tonight? Ah, voila. That works. So at least we've got that. But then what, eh? How did they get to 5? Maybe let's try the same approach that we tried last time, where we had the first 3 here, and then try to come up with some kind of algorithm. So let's say that we have just 16, 1, and 2 for positions. If we then want to find the most optimal, well, let's first try it between 16 and 1. If you, which one would that be? So going from 16 to, and now I need to make sure that if I do 16 to 1, what would that be? That's the issue with this kind of stuff. I can't calculate that off the top of my head. My math is bad as it gets already, so 120. It's always going to be 120 here. Whether or not you move from 1 to 16, or you move from 16 to 1, or I guess if you, maybe if you move to the middle now. So if you say I want to move to 8, in that case, it would be 16 to 8 plus 6 plus 1 to 8. And now I really want to do soft asserts. Soft assertions. Yeah, maybe we should do that here. And assert all of these softly, and then at the end we'll say softly assert all, I think. Yeah? There we go. So I'm just interested in the bottom two now, because they will fail. And one of them will be I'm gonna guess the bigger one or something will be 36 and the other one is 28. Or it's the other way around. I'm not really sure now. Yeah, this is 8 positions and this is 7, huh? So then that means that if I would move to 8, it would be moving to 8. That would mean that it's 36 plus 28, which equals to 64. That's already much less than 120, yeah? What if we do 7 or something? I don't know. Let's do 7. So first it would be 45 and then it's 28. Moving to 7. 45 and then 28. Yeah, that's already higher. 73. And moving to 6. Or moving to 9. What would that turn into? I guess we don't need these anymore. What would these be? Gee, toch, 9 will be same as 8. Why is that? Because it's also 7 and 8. Oh, yeah. It will be 28 and 36. Yeah. Under that. Yeah, it's the same, huh? I feel like the middle is very promising because it seems like it's going to... Now it is important that we find that middle position, in fact. And it's not just the middle indexed, let's say. So what we need to do now, I guess... nee, that won't work because it will still be an amount, like Topher said before, if you have 10 positions at 1. Doe maar. Average instead of median. Sure, yeah. What I mean is, let's say that we have 16 to 1. The way that I would, or if I have 16 and 1, the way I would do that now is I would just generate, median is, yeah. yeah, maybe it's the average then. Yeah. So if I say it's if I generate from 1 to 16, I guess I already know that, huh? Because 1 to 16 would be the actual middle, so that would be 8, like I would just, like I said, huh? That comes down to just dividing 16 by 2, and then I would get quote unquote the middle, and it would be good enough. But then that won't work for a case where you've got something like that, and then 16, then it's no longer correct. I don't think the average, how do you, what's the average of this? Is there a thing for that? Ja, zeker. Softly assert that this stuff is equal to, I don't know, something. 7. Here, 6. Why not? Oh yeah, fuck. These were incorrect. .5. Oei. So that then would mean whether or not I move to 3 or I move to 4, does it matter there? I guess it would, huh? So if I take 16 to 3 or 16 to 4, this would be less, but then I also need to do 1 to 4 and 1 to 3. Oké, wacht hè. So this would be 3, this is 6, and then this is 78, and here it's 91. So if I do, wacht hè, how many ones do we have? 5. Let's say we'll do 5 times 3. So that's 91 plus 15. 91 plus 15 would be 106. Am I? No, it's 116. Jesus, am I so? Yeah, that was 106. And then if I do 6 times 5, what's that? 35, I think. No, just 30. So that's plus 30, but it's less than 91. It's 78. And 78 plus 30 is 108. So I guess it does matter unless I just miscalculated. So here the lower number, so rounding down would be better according to whatever I dreamed up here. Huh? Okay, let's try that. Let's just try it out. It's a good guess. Huh? You've got some bigger tests there. Okay, so if I check, yo, input, give me your average. And then this would be, man, how did I call that in day 7 here? Grab in the middle. So maybe it's not grab in the middle then, but average. Or probably best position or something. And then we'll do divided by, or rounded down, round to int, yeah. Ah, shit. Yeah, you're right. I guess it sort of depends then. If I do round to int and the solution works, it might not work for a different entry set. Are we happy with that? I think I am. Anyway. I don't know. It's probably it's not a great solution. I guess what we could do is just find out how many like how is the distribution? What's the distribution like? If we've got more above it, both up and down. What do you mean? Try it twice? That I don't understand. Anyway, so probably best pos, that's my guess. And then I want to return, so these are positions, not just input. Then when I have the current diff to probably best pos, and then what I want is to calculate, maybe no, it's not this, but it would be, oh fucking hell, calculate fuel spent from my current position to this one. I think that's it. Calculate cost for rounding down and cost for rounding up. Ah yeah, of course. And then, yeah, why not? That's a great idea. And then just choose the best one. Yeah. Yeah, I don't know if it is. It's just a guess for now. This would be rounded up. No, rounded down, sorry. And this would be rounded up. I don't know how to do that. Rounded down plus 1. So really it's this plus 1. And then we'll do rounded down. And then we'll choose the minimum between these two. And I fucking threw that shit away, of course. Optimal fuel cost with rounding down. And we'll do the same rounded up. Rounding up. And then it's if optimal with rounding up is smaller than the other one, then we'll return that one. Else we'll return the other fuel or calculated fuel cost. Okay, I am confident. Wait, we need to return this if. And then move all of this crap to production code. which lives in our main. Ah shit, I never created a package for that. Let's first move it. Zo. Maar jong, wat? Ah, hier. Voilà, it seems to be compiling. Let's move this thing to a day 7 package. That's just in the case when I have multiple classes. Let's see if I ever did that. Not a single day. Yeah, cake. Whatevs. Min AB is valid. Malay, are you serious? I tried that. I tried that. Okay. Cheers for that. Let's see if that works. So if we go back to that test, we already had some tests for solve 2. We've got expected input here. I mean, we've got input and an expected outcome. Pray for me. Pray for me, folks. See, the thing I don't like is that it was a guess, huh? Oh. But I guess that was correct nonetheless. Excuse you? Too high? Wadu, wadu, wadu. And the worst part is that I no longer have a test that can be used to discover what is going wrong. Oh no, I hate to be in this. I hate to be in this situation. Fuka. Maybe the +1 is oh nee. Very curious, huh? Round to int is not down. Mayo. Is there a way to just say round down? Oh, really? What does this return? double. That's sad, huh? Okay, there's just, yeah. And then these you want to do to int then, huh? Voila. And then if my, tja. The issue now is that if this is correct, less than, then I don't get the output. So let's print it, I guess. Let's run all the tests. Well, it was green and it's lower, so it should be this one. So now I can do equal to. Should get rid of the dot also. I'll try this. Yeah, hallelujah. Oh my god. Thanks for sticking with me through that, young Topher. I would say your contributions were invaluable. This is the second time I had viewers help me out. Solve day 7. Math makes my head hurty. If the input were different, your code could still fail. Wait, why is that? So you're saying I just got lucky or what? Christ. You know what the funniest thing was? Yesterday when I was shooting the shit with Amarth on stream, I was like, oh, you know, it just feels like I could use I need to get the mean or find the mean to solve this problem or whatever, or find the mean or the average. Look who was right, eh? My gut feeling. Ah, yeah. Yeah, so you also did the plus minus and then take the most optimal fuel cost there probably. Okay, let's see. Is 8 an easy one? I saw it earlier today and it didn't look like an easy one, but it sure looks like fun. So maybe let's first read it. You barely reach the safety of the cave when the whale smashes into the cave mouth, collapsing it. So now we're in a cave system. That's really cool. Sensors indicate another exit to this cave at a much greater depth, so you have no choice but to press on. As your submarine slowly makes its way through the cave system, you notice that the 4-digit 7-segment displays in your submarine. Why is it 7 segment? 1, 2, 3, 4, 5, 6, 7. Okay. In your submarine are malfunctioning. They must have been damaged during the escape. You'll be in a lot of trouble without them, so you'd better figure out what's wrong. Each digit of a 7-segment display is rendered by turning on or off any of 7 segments named A through G. Excuse you. Any of 7 segments named A through G. Ah, yeah, I see now. So this is the A segment, this is the B segment, the C segment, the D segment, the E segment, the F segment, and the G segment. Okay. So to render A1, that's just those two here, you have to turn on C and F. The rest would be off. To render A7, only segments A, C, and F would be turned on, yeah. The problem is that the signals which control the segments have been mixed up on each display. How many displays do we have? Ah, what? This is one display. Mixed up. The submarine is still trying to display numbers by producing output on signal wires A through G, but those wires are connected to segments randomly, whereas the wire/segment connections are mixed up separately for each 4-digit display. All of the digits within a display use the same connections though. Yeah, so so we have 8 displays to fix, and every display has a randomly as random connections basically. You might know that only signal wires B and G are turned on, but that doesn't mean segments B and G are turned on. The only digit that uses 2 segments is 1. So it must mean segments C and F are meant to be on. Wait, what? The display should be displaying 0, 1, 2, 3, 4, 5, 6, 7, 8, 9? Let's read on, huh? Hopefully it will be here. You might know that only signal wires B and G are turned on, but that doesn't mean segments B and G. Segments B and G. So you will get signal wires for B and G. But it doesn't mean that the segments B and G. The only digit that uses 2 segments is 1. Ah, yeah, I see. So if you get signal wires and only B and G are quote unquote on, it won't make any sense because it would have this B and this G and the rest would be blank. But if you have any display with just 2 wires that are turned on, then it must mean that it is the one here. For example, you cannot make the same deduction, like you cannot deduce the same thing if these were on, because the amount of wires that are turned on are the same for 2 and 3, for example. So for 4 we've got 4, but 7 also has that. Nee, 7 has 3, 4 has 4, 1 has 2, and 0 has 6. 5, 1, 2, 3, 4, 5, 6. And then 9 is the same. 8 is the only one that's full. Okay. With just that information, you still can't tell which wire B and G goes to which segment CF. Why is that? It's just, you still can't tell which wire, B or G, goes to which segment. Ah, yeah, yeah. 9 is afraid of 7. Afraid. I don't get that. So yeah, if you can just determine it's supposed to be a 1, but which wire goes to which segment. Oh my god, holy shit. It's too late for word ponds, Topher. It's too late for those. I need another beer to properly enjoy that. Maybe so. It's actually it's not. It's too early. So for that you'll need to collect more information just to be able to deduce. Then for each display you watch the changing signals for a while. Make a note of all 10 unique signal patterns you see, and then write down a single 4-digit output value. Use the signal patterns. You should be able to work out which pattern corresponds to which digit. It's the mean of too late and too early. I think I'm going to get nightmares. This text though, look at all of this fucking text, oh my god. Here is what you might see in a single entry in your notes. So 1, 2, 3, 4, 5, 6. What the fucking hell, I can't count. So these are indeed 7. 7, that would be the 9, eh? 1, 2, 3, 4, 5. I am lying. 4 plus 2. So this is the 8 then, I guess. But you don't know in which order that they go. Then it's CDFB, which is, I'm going to look for the one with 2, A and B. So that's the 1. So now you know that A is supposed to be, no, we can't really tell. And here you can't tell either because it's full, right? Which one gives me information and about which side that they're on? Ah, wait, nee, wacht, hè. Using ACDE blah, blah, and AB, we can already determine that A is on the right side of the 8, and so is B. But we don't yet know which one. Is there another way to do that? So if you have 4, well, I guess you can make the distinction between what these two are, because if these are A and B, then what are those? So the ones with 4 in it, that's this one. So E and F are these two. We know that for sure. But then you still can't tell if this is A or this is A. This is E and this is F. And then what? Yeah, if you then take if you then use the 0, because this would then not have either an E or an F, and the 0 we can distinguish because this one has 6, and that's the only one that has 6, right? No, the 6 also has 6. 2. But yeah, it's then, in any case, it's the one without an E or an F. So let's find the 2 that have 6. This one has both E and F. This one has only E, so this is the 0. Then that means that F must be this. Wait, was it E? Yeah, this is so D goes to F. We already know that. 9 also has 6. Yeah, but it's the same. Yeah, indeed. But it's still the same thing. Neither. I knew that both 6, 9, or 0 segments or displays should not have either an E or an F. And it's the one that has not an E or an F, which is this one. So this is the 0. My god, ding, dat is moeilijk. What is the delimiter? Each entry consists of 10 unique signal patterns. These are 4, 5, wacht hè. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah. And what are those? What are those? Finally, the 4-digit output value. Dab, then you know D is on top. Wait, why would that be? Oh man. Is that still going on to the, with the, that's the one with 3. So that's, yeah, voila. Yeah. Yeah, and so on and so on. Then what? Each entry consists of 10 and then the 4-digit output value. Yeah. So this is the actual output. Yeah. It's a clock. Where does it say that? It's all of them that are malfunctioning. But yeah, anyway, so this is what it's supposed to be showing then. Within, these are the wire signals basically. Okay. Then what? Within an entry, the same wire/segment connections are used, but you don't know what the connections actually are. The unique signal patterns correspond to the 10 different ways the submarine tries to render a digit using the current wire segment. 7 is the only digit that uses 3 segments. Here. Dab in the above example means that to render a 7, signal lines D, A, and B are on. Yeah, correct. Because 4 is the only digit that uses 4 segments. E, A, F, B means that to render a 4, signal lines E, A, F, and B are on. Using this information, should be able to work out which combination of signal wires corresponds to each of the 10 digits. Then you can decode the 4-digit output value. Unfortunately, in the above example, all of the digits in the output value use 5 segments and are more difficult to deduce. Wait, what? In the above example, all of the digits in the output value use... yeah, I see. So this these are all 5, so you can't really tell which one of those it would be. Your code is a lie. You have to read the assignment, Topher. Yeah, it's difficult. Fucking hell, yeah. Focus on the easy digits. Consider this larger example. Why are they highlighting these? I mean, why is it important that they are shown? If you get the input list of all of the displays, then you should be able to deduce how the connections are wired, no? Or are they just saying these are the easier ones, so try to figure those out first or something? Each use a unique number of segments. 1 for 7 and 8. Yeah. 4 uses these. 7 and then 8 has them all, yeah. Each use a unique. You should be able to tell which combinations of signals correspond to those digits, yeah. I see. Counting only digits in the output values. In the above example, there are 26 instances of digits that use a unique number of... Oh, sorry, what? You should be able to tell which combinations of signals correspond to those digits, yeah. So they first want me to deduce the... voilà, here. How many times do digits 1 for 7 or 8 appear? Wait, but isn't that just counting how many... Just checking the output? Because the moment you've got either a 7, an amount of 7, wacht, because 7 has 3 segments, 1 has 2 segments, 4 has 4 segments, and then 8 has all of the other segments. So 1, what's that, 4, 7 in total. So we should just look for outputs that either have 2, 4, 3, or 7 letters, and then that's the amount of times these digits appear. Nee? The weird... There are 26 instances of digits that use a unique number. Yeah. I see. Yeah. This seems like a very weird... because he sets you up for this really complex thing and then just asks the most simple question. Okay, I think I can do that still, huh? Let's do Kotlin day 8.day8, yo. Sure, yeah. We are having some fun solving one. Let's take as input the list of strings. Cha. And then it should return an int. And we need to do this thing. Solve2 will probably also take that thing. And I bet it's also going to return an int. And now we can just create a new test for day 8. Let's put that in day 8 as well. Yeah, thank you. Thanks, IntelliJ. Get rid of this fucking Jupyter assertions. No one Solve one with test input returns 26, I think it was. You might be wondering why I always keep on removing this internal thing. I will show you why. If I run this test, it will fail, obviously. But let's put my cursor here somewhere. And in the meanwhile, maybe I can put some resources in here. Directory. Oh, okay. No tests were found. It's even worse. So if I run all of the tests, then it does work. And so I can run this class. But then if I navigate or try to navigate to it, it no worky. If I double click, it no worky. I get rid of the internal. I rerun my tests. And I navigate to the test. There you go. So, I mean, poopies. Okay, let's create a new directory called day8. We'll put a new file in there called testinput.txt. We'll add all of this in there because that's our test input. And then here we'll add a new one, say actual input.txt. Get your puzzle input. Ooh, king hell. Yeah. Let's put those pipes. Voila. Solve 2. Oh no, wait. Solve 1 with actual input returns whatever. We don't know yet. So I want to say day8.solve 1 with money, alle kerel. So the other day my bad. I tried moving solve 1 from day 1 into its own object so that I would have a namespace for it and I wouldn't get this issue of IntelliJ trying to suggest, hey, did you mean solve 1 from day 1? Dofer, thank you so much for the help and have a good night's rest. I'm gonna code on a little bit, see if I can solve at least the first part. I should be able to do that. Let's read test input.txt and read lines. Voila. Cheers. I guess you already solved it. We'll call that actual, and then we'll just say that actual is equal to, to 26. Nice. I think we might just solve this straight away, young me. Let's run the tests first again. Oh wow, good job. Voila. Okay, so the first thing I need to do is get rid of everything before the pipe. So let's map input, because these are all of the lines. And then we'll say, can we just say drop maybe? Ah, nee. Split then. Or sub string. Oh yeah, substring after the pipe and will include the space, because then we only get these, and then those we will just split. Let's call these the digits or something, and then these we will split. Nee, wacht, hè. So first, if we select one thing like this, then the next part we need to split based on a space, and then we'll have let's call this thing line maybe. Then it'll be a little bit easier to comprehend, I hope. So these will be actual digits on one line. Let's call this snarf. Then for every digit, what I want to do is just count. So count. What we can do here is assign the type. So this is just a digit basically, or a wire digit, and we just need to count how many instances. Count where it.length is either in, what was it again? Yeah, you will learn soon enough, IntelliJ, don't worry. So identifying a 1 would be 2. Yeah. 2. 4. 3, that's the 7, or 7, and that's the 8. And if we get rid of these, or want to get rid of these magic numbers, yeah, by the way, we just need to sum this and then return it. And apparently we can merge. So I still want to, yeah, maybe let's try to run it first and see if it works. Oh, it doesn't work. Oh, oh, oui. Ah, yeah, of course, it needs to be day 8/test input. Oh man, I never checked the output. Okay, voila. So that seems to be working. Yeah, then we can try it with the actual input. Just try actual input. Run it. Three, 4, 9. That should be the solution for the first one. Yep, okay. But then, now I guess we're going to have to deduce some stuff. The unique signal patterns would correspond to the following digits. Yeah, so now we need to be able to actually decode it. Okay. So this is much more difficult than this is. Maybe he's trying to send us in a good direction with it though. And I wanted to get rid of these magical numbers first, so let's try to do that. What is this? Amount of signals to display 1. And then we'll do the same for 4, 3, and 7. So 4, 3, and 7. So this one was to display a 4, this one was to display a 7, and here it's to display an 8. It will be a little bit more readable that way, I guess. It's my guess, huh? At least it's clearer. Like what these magic numbers are. Okay. Can be constants. Voila, it should still run. Yeah, I think what he tried to do is to set us up for a path. Or to set us up to determine how to get to a 1 or a 4 or a 7 or an 8. Maybe it's just using these unique displays that we can, well, only those, I mean, to deduce which one, which wire belongs to which segment, I believe they're called. Signal patterns. Signal wires and segments. Yeah, I think so. The segments are okay. Shoot. Let's commit this for once. So let's solve day 8 part 1. Ja, jong, commit dan maar. It is 10:05 already though. I guess if we already find... Wacht, hè. So how did we do it before? Was we started from the 8 or something, or from the 0? I don't know, remember. Wacht, how do they do it? After some careful analysis, the mapping between signal wires and segments only makes sense in the following configuration. It isn't 8 here though, how they have mapped those quote-unquote segments. I think what I want to do is try to build up a decoder. So how do you explain that. Let's try explaining it. I'll try to build up a decoder. So we'll have a decoder class. A decoder knows which signal is connected to which segment. A completed decoder knows which signal is connected to which segment. So if you then feed signals to the decoder, it maps them to the correct segments, which should then show or like be mappable to a digit. So it's signal decoder digit. Or no, incorrect. Segment. And if you do this for all, I don't know how you write that, something like that. This should then be turned into a digit, I guess. Or what you could also say is that a list of signals can be turned into a list of segments, which turns into a digit. Something like that. Yeah, this is better. There you go. So that's what I want to be able to do. And then of course, to try to, this would mean building the decoder, but then that doesn't mean figuring out how the mapping should go. I think what we, and then how to deduce which signal is wired to which segment. That approach I don't know how to do yet. Okay, we can already start writing some stuff for that, because we know that this thing here, ACEDGFB, would then be 8. I'm wondering if the order is important here as well. I don't think we can consider the order to be important. Nee, that's why they said for every display, a segment, no, a signal might be wired to a different segment, but at least you get the correct, how do you call this thing? Signal? I don't know. So determine what determines a 7. It's easy. It's just the one with 3. We already know that. Same thing for that. That's not really useful, I guess. The thing between 7 and 1. Ah, yeah. Here, that's why Coder Assault mentioned. If you know AB for 1 and you find the thing that doesn't correspond, then you've got the top bar. Yeah. If you have a 1 and the 7, then you know segment 1 is a char that isn't used in one. Yeah, voila, indeed. Yeah, now I understand what you were trying to say. Yeah, and it's the same for the 4 here. Eh? So if you compare the 1 to the 4, the ones that are not part of the 1 are the ones that are that like the, how do you say that? The little corner. So then we have, yeah, then there's not yet a way to, gee, I already forgot. I did it on stream. Fuck. I think we compared it to 6 or 9 or whatever, or to 3. Yeah, but we can, that's like the deducing part then. But the thing I wanted to check first is, can we use these? Because this is called DAB, but really it should be mapped to ACF. That's what I wanted to map to decode to. Yeah, so we figured out, we can figure out that for this example here, DAB is literally ACF then. Yeah. Okay, nice. So this will give us the input to write our decoder, so that at least our decoder works properly. Okay. Yeah, and now I'm wondering where I should put that. Directly in the test first, maybe? Damn it. Let's first wrap these, so then that way I can run them separately. Inner class solution tests or something. Let's call these nested, and then we'll add another nested class. Let's call it Decoder Tests, and then we can create a new one where we say Jamea. Given example mapping or something, can produce or can decode signals to digits, basically. That's it. Okay. So now we can try to also already try to think of the API of how we are going to build our decoder. Let's just imagine that we can create one first. Our decoder builder or something. And that we can then just say how would we say that, with or something? I don't know. Map with. Let's just try to figure some things out first. So with, and then we can say, what was it again? D to A, D to A. Voilà. Then we can also say A to, what was it? A to C and B to F. And this could produce, and then we just need to say build or something. Yeah. something like that. So if I then pass it a list of signals DAB, then I can produce the digit 7. That's the idea. So if I then say digit, I say decoder.decode, what was it, DAB, then this should become, maybe we should call it like that. So this would be the display, yeah? Something like that, I don't know. Or an integer. It's difficult. Keep it simple, stupid. Digit is equal to, voila, 7, something like that. And then we can write our decoder builder somewhere here. Oh yeah, we can actually just say, this doesn't have to be a class, I guess. Oh yeah, maybe it should be a class first. Let's make it a data class, because then I can yeah. Sounds like a map, huh? Map or something? I don't know, young. Fucking hell. Map, which is a map of one character to another. And then we say it's in fact a map. And then we can say by map. Then we can do some fancy stuff with this, I hope. Let's create an empty one. Voila, and now our width thing. So when we write fun width on the decoder value, then this thing should take a pair, voila, mapping called a pair from one char to another char. This should return a decoder builder, and this should return return a new decoder builder with a new map where we say the existing one. So map, can we do that? Plus, is that useful even? Map using list of mapping to map. That works apparently. And normally when you build that, if we then say fun build, this should return a builder, then we can just say return, oh, we don't have a decoder yet. Let's call it another data class, don't know why. Maybe it doesn't need to be a decoder. It doesn't need to be a data class, so our decoder thing will be a decoder that takes in also a map of chars, and then that needs to be initialized, so that means we can return a decoder that uses this map. Here we need to say decode. Then we say we've got a new function called decode. which takes in a string. What do we call these? Wire signals, wire signals, which is a string, which happens to be a char sequence. Maybe it's better to type it like that then as well. And it should output a digit really. So let's call that digit. And we can just type alias digit to an integer. And what we then need to do is for every character in wire signals, we need to, no, that's it. We need to say, we need to map. We need a map to be mapped. Nee, we need to do the wire signals. And we need to map every character in there to return the corresponding one. So what we need to do is use the map and get it. Because D would become A and then A would become C, etc. This then produces, I guess, a new string or something, and with that string we should be able to decode that thing into a digit. So maybe we'll keep a map of digits then, which is a string, and it returns an int. And we need to initialize this one by saying list of, and now we'll do ACF to 7, to 7, etc., and we say to map, and then we've got the digits. And then what we should do here is basically say return digits for this one. And what we should do instead is explode, so we could do that probably. Ella, what's going on? Is this not returning a string? Apparently not. Okay. What if I turn this into a string then? And I don't do this? No, same idea. Okay, then this should better be char sequence. Okay, cool. That's the idea. Yeah. Yeah, now we just need to declare what the other numbers are looking like. So we just cheat. I'll let cheat. So this one is A, B, C, E, F, G. E, F, G. This is 0. Then we've got the one which is C and F only. Then we've got A, C, D, E, G. 2. Then there's 3. A, C, D, F, G. Then there's 4, which was B, C, D, F. 5, which would be A, B, D, F, G. D, F, G. 6 would mean A, B, D, E, F, G. A, B, D, E, F, G. 7 we have. 8 would be all of them, A, B, C, D, E, F, G. And then finally 9, it's everything without the E. Am I? Yeah, great. So I guess, what the fuck is going on? Oh, my bad. So if I then pass DAB to this decoder, it should equal 7, huh? Because we built DAB to become ACF, which happens to be 7. All right, let's do it. No, okay. So there's that, and I guess what we should do then is try, oh, I think this is already fine, I know. Because if you, what if we add some extra stuff, we say also that ACF, so we already, with this, we can also say that if we do A and B, that our second digit is equal to 1. Yeah, because A gets mapped to C and B to F, and that would be CF. Voila. Yeah, and I guess no, I think this is okay. And then yeah, the reason why I wanted a builder is so that I can I wanted a builder so that I can gradually build this thing the more I deduce, basically, yeah. And then eventually when I'm done, when do I know when I'm done? I guess I know when I'm done when I've got 7 entries in my map. No shit, allez. Yeah, it is 7, A, B, C, D, E, F, G. When I have 7 entries in my map, it should be complete and build should be called. So here, maybe if I do if map size is less than 7, we need to throw an exception. I don't care which one, so maybe what I should do instead is say check or something. Yeah, voila, check, and then a lazy message. Say tried building a decoder with an incomplete map. You'll need seven minus map.size more. So that should be helpful information when we try to call build, but we don't have enough. in our mapping. Now I'm wondering why I did this, because I'm not using that stuff at all. Eh? So goodbye with that. I could also try putting these functions inside the decoder class, but if I do that, then yeah, or what I should do is move this here, because that way, yeah, let's do that. Because then you could try creating a decoder with a map. So if I say init like that, then you can never construct a decoder using a map with a map that's incomplete. I guess there should be more checks, like these should all be unique keys, but that's already implied because it's a map. Oh no, that's not what I meant. So these pairs should all be unique, in fact. And they should all be going from A to G. Same for this one. Maybe we can do that. So check map.keys. Contains all A to G. I think you can do that. Me? To list string, join to string. Oh, wacht. There we go. Tried building a decoder. With unknown signals, I guess. And then we'll do map.keys. Should be okay. And then we also should try to do the same thing with values. So try building a decoder with unknown segments. And here we'll check values. Voila. Cool, 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 cool. Oh. Voila. Oh, and the G is in this thing is inclusive, right? So if I go to my Scratch file again. Yeah, it is included. Nice. Okay, so this gives us some validation when we're trying to build a decoder and it's going wrong. So this is instead of writing unit tests. Now it can just fail using these things. It's quite safe. We've got these digits mapping. I don't really like that it's inside of the decoder class, because it's a decoder that's always going to do it, but in theory it shouldn't be. It should be part of the display class or something like that. Man, this is already good enough. Okay, I think I'm about ready with that stuff. But now, how to deduce the mapping, yeah? So that we can call these with functions. For that we have to go back here. Well, we can already know that based just on the length of those things, of these strings, that we know which kind of digit that we're dealing with. So this is an incorrectly wired 7 because it has 3 segments, or well, wires. This one is a 4, this one is the 1, yeah, and then this one is the 8, but maybe not in the... Oh wait, this is not really useful, I think. So if we find those, we find the 2 and the 7, then we can start deducing. If we just take the 1, no, the 7 and the 1, we already know that the odd one out is the top one. So then we know how to define the A. It's the odd one out. Now I'm wondering if we should reference those segments with letters, because I don't really like that. You could go top left, top right, middle, bottom left, bottom right, bottom, for example. I don't know. Let's write another inner class. Call them the Deduction Tests. Using or given signals for 7 and the 1 can deduce the A segment. That's really what I wanted to test. So if I have a string that says DAB and AB, I believe, and I say deduce this thing or something, what do I expect to come out of this thing? A decoder builder, maybe? And how am I going to assert some stuff on that one? Yeah, maybe. Oh, now it would have been useful to go like this. Let's just try doing it like that. get oh god. So the corresponding get segment or something. Nee, get signal and then signal for A, which is gonna be called a segment, and it's going to return. Okay, I'm gonna call that. So then we do signal. This thing is called. Let's call it a signal. And then, oh yeah, then our chars suddenly become something else. So this one is the signal, and this one is gonna become the segment. Same here. Voila. And then we just add some more type aliases, don't we? Type alias signal, which is a char, and same for segment. Voila. Yeah, and then is equal to D. So, okay, let's add this one. This is the segment, and it should return a signal. So now it should return map fucking hell, find. Nee. What does that do again? Yeah, filter values. We want to create this where the segment or it equals segment. This should return a map containing all key value pairs with values matching the given predicate, which is a single one. So it's this one, and we should get the key from that because it's a first. What the fuck? What does this return? Show me the type, man. A map containing only, yeah, so really it's filter values, and we want keys of this one. Nee? Hold first. Yeah. Yeah, that's it. Inline that stuff. Ja, jong. Okay, that should be it. Yeah, and then our function deduce we don't have yet, so let's create that thing. Deduce takes in a string. How do we call that? These are signal pattern, a single one, which is a string. And then it should return a decoder builder. And we should return with a capital B Let's start off by creating a decoder builder. Yeah. So if we, again, split this one by space, then we supposedly have all of the encoded digits. Encoded digits. Or badly wired or something like that. And then what I can do is basically say in the encoded digits, find the single one. So first, that of which the count equals to 2. And this one, again, it's the magic number, but this one is basically the encoded one. If we do the same thing to get the 7, it's the one where it's 3. The encoded 4 would be this one. And then it's encoded 8 or something, where it's amount of 7. Don't you need to keep the same decoder builder to add more items to the map? Yes, that's correct. But yeah, how am I going to explain? That's why I want a decoder builder. So eventually I will need to return this one. So if I deduce a single pattern, then I can, wacht hè. So we will always have one decoder builder for every line, I think. So using this, it should give me a decoder builder that is able to decode these encoded digits. Same for this one, same, etc, etc, etc. So as I'm splitting all of these signal patterns up in a space, and I apply the deduce function, my hope is that I can gradually build a decoder. So if I have these, then I hope at one point, I know now that I've got the encoded 1 and the encoded 7. I just know, so if we check which one doesn't belong, so if I check, how do you say that? The diff between encoded 1 and encoded 7, I guess. So encoded 1 diff encoded 7. This should return me the character that's different, which would mean it's the top one. So this is the A segment. Well, nee. Was it called segment? I think so. Segment A. And then I would be able to go like builder dot. Let's do that. Builder dot width. So I say, maybe you want to mean that I need to do this, so that I always reassign builder width. Signal to segment, so it's this is incorrect. So this would be the signal for segment A. So signal for segment A. So that would be signal for segment A to A. That's it. And then I already have the A. Hooray. And this is my idea to, yeah. I'm not sure if it's gonna work. I don't really know what else to do, in fact. Yeah, wacht, maybe something else that I wanted to add is the moment that you have something that you can mutate by returning itself is you can just pass this thing along, because all of the functions that I plan to write are all deduction functions basically to determine every single segment. So if I wrap this in a function and I pass my builder to it, that wrapped function is going to return the builder. And then I can just put all of those functions in a list, loop across all of those functions, and when I loop across all of those functions, it will return me with a builder, which I think can then return and then say build, and then we should be good. So let's write an extension function diff on string that says other. It should return, I guess it's another string theoretically, because isn't there already something like that? Substring or something? Yeah, wait, if I order them first, so if I order them, sort. So I just want to shuffle them around and then do and then use substring, because that will just return me the other string. Yeah. So if I can write this dot or maybe I can just find all or something. What would this do? To list, and then yeah, I want the ones that are not, of course. Now maybe it's just like that. So filter it not in other to list. And then join this to a string again. I think that should do it. It's a bit wonky, yeah? But then that returns a string, and it should contain, yeah, that's the annoying part. If it doesn't contain 1, then it should explode. So this is gonna be deduce segment A, basically. And then we can see that it takes and an encoded 1 and encoded 7 and then the builder, and it returns a builder. But now you can see that I don't have to make this a variable, because I can just say return builder with that thing. So here I can say signal how am I going to do that? Can I just go like that? I mean, it should be okay, right? And then we've got segment A. And then my plan. Yeah, I think it's gonna be interesting to also query my builder at some point, just to figure out, do you already have A, for example? Oh god, I have to stop streaming and it's already 11. This is a fun puzzle, this one. It's not a mathematical one. I can think how to implement it, even though it's quite how do you say, it's quite one-to-one with the way that we're deducing things, huh? Or maybe that's okay. Which one was the other one that we could still do? It's the one with which has a 4, because this allows me to at least. Wacht, hè. That's the 7. No. And A, B are the ones on the right. So this either gives me two options. Either it's an E or an F. And how did I know again? If I have the 0, I think you can call the filter on the string without the two. Ah, okay, that's a good optimization. Ah, yeah. Then you don't need to string that thing anymore. Oh, yeah, that's cool. Oh, nice. Cheers. Can we determine? Oh yeah, we already know which side that these are on. So we know that these are on the right, but not in which order though. The 7 won't help us with that either, and neither will the 8. I guess we could determine the B segment again by doing what? I forgot, yeah. Maybe if you try to get the 6, was it that? If you compare the 4 to the 6, then we know this top one. And is there a way to determine the 6? 1, 2, 3, 6, 1, 2, 3, 5. Is there another one with 6? Yeah, the 9. If you have 6 characters, because the 0 is also 6, but the 9 was also 6, and both signals of 1 are in, then it's the 0. Yeah. But then you could also have the 9. Yeah. Well, you know that you will have the 6 because the 6 doesn't contain all of the 4. So 9 contains 4, 6 does not. 0. Maybe we should take that kind of an approach to say if you compare. You always need to go both ways, I think. Yeah. So if we take 4, 0, 6, and 9 into consideration, can we then deduce which one is which? Because that will already be helpful as well. Eh? So given 0, 4, 6, and 9, we should be able to deduce that this is the 6, and because both 6 and 9 will have a middle one, which which the 4 also has. You can't really say if nee. Oh my god. Okay, I'm getting too tired and I just need to get ready for bed. Fucking hell. Damn, I'm really sorry to disappoint Coder Assault. But there is this point where you have to call it a night. If you have the 2 characters of 1 and or both not on a 6, then it's a 6. I think, maybe given 1, 4, 6, 9, and 0, then we can probably determine which one is which. But it still would need to take some steps. Where I think we just need to try out some stuff and then write some tests, see what hits, what doesn't. A bit like how we approached the day 7, just by guessing a bit and seeing what sticks and then fixing stuff. All right. Okay. I'm gonna call it. Yeah. Let me. I think my tests should be failing. At least. Let's run all of them. At least it shows my approach, and I don't think I will forget it anyway. Yeah. Excellent. Oh yeah, what? Ah yeah, of course, that this no longer works. Oh. That's annoying. Now I have to just guess the other ones or something. I don't know. Before I used to be able to no, Duma. This one I think I can just do yes, let's do that. To do complete decoder builder with example mapping. So and then the other test is failing because contains no element. Oei. Nee, alleen at 126 doesn't exist. Deduce collection contains no. I don't know. It must be this one or something. I don't really know. All right. Yeah, me too. All right. Maybe see you tomorrow. I'm not really sure if I'm going to be live coding, but we will see. And otherwise, I'll see you next time probably. Thanks for hanging out, and have a good night's rest and enjoy Advent of Code. Deuces. See you.